Hello everyone. This is a presentation on the Phobos Exploration and Investigation System. So about Phobos, it is Mars's largest moon, but it is still very small compared to the Earth's moon as it has a radius of only 6.9 miles. The temperature on Phobos ranges from about 25 degrees Fahrenheit to negative 170 degrees Fahrenheit. It has a meter-high blanket of regolith on its surface, which is a loose combination of rocks, dust, and other materials. It also has a very low gravity of only 0.0057 meters per second squared. So the problem we need to overcome is to create a device that is able to collect a sample from the surface of Phobos. This sample would help uncover the physical makeup of Phobos and provide information that could be used for potential mining operations on the moon.
Here's our final design of the model we created of the Phobos rover. We can clearly see the three chief components our rover utilizes, namely there are the gray train, the boring device, and the continuous tracked wheels. On the right, we can see the top view of the design. And here is the depiction of our design of Phobos, showing the concept of cylinder inserting the surface of Phobos.
The gear train, the track and wheel mechanism, and the boring device. The gear train will consist of 3 gears per wheel for a total of 6 gears per side. They will be mirrored on both sides and will provide identical movement to both wheels on one side of the rover. They will be made out of a low carbon steel for low applications in cold environments. For the track and wheel mechanism, that was inspired by the movement mechanism of tanks. It uses a chain of tracks to traverse harsh terrains, and the tracks will be run by sprockets connected to the gear train. The boring device was inspired by ice core machines, which take samples by inserting a cylinder into the ground. It will use gas pressure to move the boring cylinder into the surface of Phobos. The following are the constraints that the machine must follow. The rover will be able to store a column of dust from the Phobos' surface. This will be done by using the boring mechanism. The rover will counteract the normal force produced by the boring mechanism by emitting pressurized gas from the chassis of the rover. The rover will be fully assembled and ready to use before launching into outer space, and it will be designed to withstand potential failures, allowing the rover to be operated for extended periods without repair.
These are some of the hand calculations that we did to determine the best arrangement for our gears, but they're better illustrated in the next slide where they are organized and they have little comments about them. So here on the left, you can see all the values that we got, and on the right, you can see what they are in their units. We calculated the smallest number of teeth without interference for a 1-to-1 ratio using a module of 1 and a K equals 1 value for full depth teeth and a pressure angle of 20 degrees. And we also calculated the pitch line velocity of the gear teeth as well as the track sprockets, so we could figure out how fast the rover will be going, which is equal to the pitch line velocity of the track sprockets. And we also calculated the transmitted load with the values that were inputted here, and the stress that we calculated with the Lewis bending equation. We are using a motor power of 0.2 kilowatts, which is 200 watts, and here we have a plot of stress versus face width, where we plotted from 3 pi over the diametral pitch to 5 pi over the diametral pitch for the face width value. And that's a step size of 1/10. And the design at our set face width of 14.5 centimeters is nowhere near the allowable stress for a factor of safety of 5. And you can also see that the data agrees with the Lewis bending equation here because the stress is inversely proportional to the face width. As the face width increases, the stress decreases.
Now that we've reached the end of our presentation, so one thing that we need to discuss are the expectations of our design. As since our design will be on the planet, one thing that we wanted to ensure was that our design would be able to travel through all types of terrain and withstand the icy conditions that may be ahead of it. Our main objective is for the rover to be able to travel and collect samples of different types of grounds on the moon through the use of the boring type mechanism that we've installed on it. And a few calculations that we would not have been able to have done without the lectures that we've attended for our mechanical systems design class include the factor of safety, the gear and teeth calculations, and then even we wouldn't have been able to determine the material based on yield strength without this class. And then here are our references. Thank you all for your time.